welcome back Year 9, exercise 4K today, looking at solving simultaneous equations graphically. What does it look like when I draw a graph of the two equations that we're given, and what does the solution look like? And basically, the whole point of this exercise is when we're finding a solution for simultaneous equations, what we're actually doing is finding where the two lines intersect. If I was to draw those two lines on the same set of axes, I'd be able to find where they intersect. The coordinates of that point of intersection, they are the numbers that will satisfy both equations at once. And that makes sense because every point on the line is a set of points, is a set of coordinates that will satisfy that equation. To find one point that will satisfy two equations, well, it has to be on both lines. And so when we're talking about linear equations, there's one point where that will usually happen. Now I say usually because there are a couple of situations which we haven't really looked at yet, maybe only briefly, where there are no points of intersection. And they talk about that in this exercise here. They bring it up a little bit. It doesn't want to scroll for me at the moment. Oh, now it wants to scroll too far. There we go. It's just waking up this morning. So often we'll have two lines, point of intersection, easy to find. We can find it algebraically using elimination or substitution. We can also sketch both lines and find it graphically. It's probably best if we're going to do that to do it using technology like a graphics calculator or Desmos, because that's going to be able to do it accurately. If we're sketching these lines by hand, it's going to be a little bit inaccurate because we're not perfect at sketching. So there is that to bear in mind. However, if we can draw accurately for most purposes, we're going to be able to get a close enough answer. Let's look at this situation where it says two parallel lines. There is no intersection. Well, you can see, like railroad tracks, isn't it? That's how you've probably heard parallel lines described before, even though they have some bends in them. Parallel lines, if they continue in a straight line, they're never going to meet in plane geometry. So the geometry we're dealing with, there are some special cases where they always meet. We'll get to those one day when you start exploring exciting curved surfaces and things like that. But essentially, parallel lines, for all intents and purposes, they're never going to meet. So you would think there'd be no intersection. And we're going to have a look at Desmos here, and we can see an example. Here I've just got two lines. Remember that MX, I've called it K. Let's call that C, because that's what you actually work with, isn't it? Why would I call it K? Y equals mx plus c. So here I've got just an equation, 3x plus 4. And we've got another equation, mx plus c. At the moment, the gradient's 0. What happens as I adjust this value for c? You can see what's happening to the blue equation there. The c value changing the y-intercept. What that's doing is it's moving the equation up and down. Now I chose a gradient of 0 because as soon as I change that gradient a little bit and I move it up and down, people seem to think it's moving sort of diagonally up and left or diagonally down and right. It's actually moving straight up and down, but as that line moves up and down, because my map, the region I'm looking at isn't infinite, it appears as though the line's moving up. But actually, if you could see the whole plane, it's all moving up, all moving down, just maintaining that same angle, the gradient. Now, we're going to talk about these ones where the gradients are equal, parallel lines. And you can see there, definitely no point of intersection. They're going to continue forever. If I change the value of c, they're never going to meet. But what happens in somewhere that blue line is crossing that red line? When's that going to happen? Ah, yes, when their intercepts are equal to each other. Now, my mouse control isn't great, but there you go. When I've got the same equation, y equals 4x plus 3, you can see that, in fact, every point on the red line matches up with a point on the blue line. That's called concurrent. Those lines are concurrent. That means they're the same line. Now, it's fairly obvious in this case because I've written them both as y equals 3x plus 4. But had the equation been 4y minus 12x equals 16, possibly you wouldn't recognize that they were the same equation. One of them was in disguise, that it had its numbers changed, we hadn't factorized it or simplified it completely. So often there'll be times when you can have equations that are the same and you won't realize it just by looking at them. But when you graph them, you can see that they're concurrent lines. And so they have an infinite number of points of intersection. So they're really careful here when they talk about this, two different lines. So as long as the lines are different, correct, if they're parallel, there'll be no intersection. if they're the same line, it could look like they're different lines, but they could actually be concurrent and the same line, just written differently. We've had Miss Barton come in and do some of the examples for you here. I think that's great because these are really quite easy to do. Deciding if a point is at the intersection, what are you going to do? Well, you substitute those numbers in and see if they satisfy both equations. That's the sort of thing you've been doing to check your answers all along anyway. So here, when I put x equals -1, I get y equals 1. Well, that's what I expected, so that's good. And in the second equation, when I put x equals -1, I get y equals 1. So that's an example, the blue one, of where it works. Part B, they're checking the point 2, -4. Well, if I put 2 in for x in the first one, I do indeed get -4. If I do it in the second one, I don't get -4. So the point 2, -4 is on the first line. It's not on the second line, so it is not the point of intersection. I suggest you try those two on the right and then check your working, and you see how you went there. To solve these graphically, yes, you can sketch graphs to do these, but I'm going to encourage you to make use of Desmos. It is possible, and that I will get you to sketch them in an exam by hand and have a look at them, but probably you want to do them by Desmos. I guess I'll do a quick example by hand first and show you how this works. So here's my set of axes. I always label my axes, y and x. Now we've got the first one, x plus y equals 4. So I'm going to need 1, 2, 3, 4. I started with the second one there. It's the first one I looked at. That's okay. It shouldn't matter for you. I'm going to use the intercept method. So the y-intercept, I find that by letting x equal 0, because the x-coordinate is 0 when I'm on the y-axis. So when x equals 0, I'm going to get y equals 4. So it's got a y-intercept of 4. To find the x-intercept, of course, I'm going to let y equal 0. And that's going to tell me that x equals 4. So you've got your second point there. You can now join them up with a straight line. Sorry, just a little interruption there. We were at the point of drawing in this line. Oh, and now it doesn't want to draw. There we go. So you can see sketching has its disadvantages. That's obviously not perfectly sketched, but it gives me enough of an idea to draw that. Let's try another line here. We'll go with red for the other line. 2x minus 2. Here I've got the y-intercept, -2. And it's got a gradient of 2, so I can go up 2 for every one I go across, and it's going to look something like that. Now, looking at my rough diagram and the fact that I didn't really use graph paper and I've done nothing to scale here, it looks like the solution's going to be 2 and 2. 2 along the x-axis, 2 on the y-axis, and we check it. If I substitute 2 in for x, I'm going to get 4 minus 2 is 2. Works for the first equation. If I put 2 and 2, obviously 2 plus 2 equals 4. It works for the second equation. So you can solve them graphically just like that. There's one there for you to try. I think this video's gone on long enough. What I would encourage you to do, though, check your answers after you've done it. Go to Desmos. Learn how to use something like Desmos. If you have a graphics calculator already, you can use that. 2x minus 2, wasn't it? And the other one was x plus y equals 2. So you can sketch them in there, click on the point, x plus y equals 4, that might be better, and you will get the point of intersection just like that. Alright, good luck with your work today, everyone. We will see you in the next video. Keep up the great effort. Cheers.